Hey guys, in this video I'm going to talk about Droop Characteristic and Droop control of the generators. Well, this topic started troubling me while I was doing my master's thesis and I was working very hard, seriously, very hard on it. Okay, and let's not go there. So have you ever wondered that people sitting in different cities in India, when they simultaneously turn on or turn off their electrical appliances, there's a net change in load demand. So how our power plants manages it? To keep it simple, this is done by droop control. Well, how? Let's find out. Let's consider what is droop characteristic with a simple example here. Consider the tap as generator, the incoming water as generated power, the water level is frequency, and the output water rate is equal to load. We can easily conclude by looking at the figure that if input water rate is maintained equal to output water rate, then the water level will always be maintained equal, which is standard frequency 50 Hz in electrical sense. Let's consider two cases here. Case 1, where if you maintain output water rate higher than incoming water rate, then there will be a drop in water level, which can be related to electrical in a sense that when there will be more load than power generated, there will be a drop in frequency. Consider the case 2, where we have more generation available to us than the actual demand. So in that case, what happens is the frequency of system increases than the standard value of frequency, which is equal to 50 Hz. The balance in case 1, the generator must generate more power, and in case 2, the generator must reduce its output power. One question arises after seeing too much emphasis is given to maintaining the frequency equal to standard value is that why is it so important? Well, all electrical appliances are made with a certain rating, and when we try to operate them below or above their rating, their useful life decreases, which is not good economically, or it might just explode. Well, droop is an inherent property of power system which tells us that the change of load will directly impact the system frequency. That is, the increase of power demand will decrease the frequency, and the decrease of power demand will increase the frequency. If important point before understanding droop control is that frequency is a global phenomena, which means the whole power system operates at same frequency irrespective of changes at any particular location. It doesn't mean that changes of a certain load affect only frequency of that load or transmission line or the generator alone. The frequency of complete power system changes. This brings us to the important point that changes in load, that is increase or decrease in the load, will increase or decrease the speed of generator rotor, which will affect the frequency. Now what Droop Controller does is that it tracks this global phenomena, and if there is a decrease in the frequency, it tells the generator to increase the frequency by increasing power generation, and if there is a increase in the frequency, it tells the generator to decrease its production accordingly. Let's now try to understand the Droop characteristic and Droop control with a MATLAB simulation model. This is an inbuilt MATLAB model. You can get it by typing this command in command window. I have added two more sections to the original model. One is this section to take the measurements of frequency and the three-phase voltage waveforms. And I have added this section also. Well, here this is a load and this is a three-phase breaker. I have added the load to show you the effect of addition or dropping of load to the power system. This three-phase breaker will be used to connect this load to the system or disconnect it to the system. This right here, this is the external signal which will give signal to the three-phase breaker. When it will be 0, this will be, the circuit will be open and it will not be connected to the grid. When this will be 1, it will be connected to the grid. And the droop control, we don't have to do anything about it because the machines in MATLAB, like Synchronous machine here, and they are already in their backend there is droop control, so they will automatically adjust to the change in frequencies no, sorry, change in load. Okay, let's run it. These are my previous simulation results. Okay. Okay, here as you can see, these are the three-phase voltage waveforms coming right here, coming from right here, and this is the frequency of the system, which is you can see 60 hertz. Well, the standard frequency of the system we kept at 60 hertz. Now, if we try to add additional load, then according to the example we understood right now, that with the addition of load, the frequency will decrease. So let's see. Here it is. This is the case. You can relate it to the example that when extra load is added, the frequency drop. But as I've told you just now, that the synchronous generators in MATLAB have inbuilt property to maintain the frequency. That is, they have inbuilt Droop control in them. So it is trying to maintain the frequency. After, well, it maintains after some fluctuations. Now let me show you the removal of load from power system. Well, from the concept, we know that when load is dropped from the system, the frequency increases. Okay, so let's check. Here it is. So as you can see that the standard frequency is 60 hertz, but after dropping of load, it has increased to some value, and then again droop control hit. So it's trying to maintain the frequency again. Well, it will take some time, but this is all. And I have not included the mathematical derivations and complete Droop control modeling in this lecture, because my idea was to make it understand to undergraduate peoples who are new to this concept. So if you need additional information regarding this, then I will give some reference of designing Droop control in the in description. Okay, thank you.